Good morning, class. We are looking at statistics, practice test number 3, module 3, covering chapter 6 and 7. Here's chapter 7, estimating parameters and determining sample sizes. Answer the following. True or false, the confidence interval estimate of the population mean is constructed around the sample mean. The answer is yes, because the formula is X bar plus minus E, CI short for the confidence interval. So we start with the sample mean and we add the E. Now, how do we find the E? Sigma of X bar is sigma over square root of N, and E is Z alpha over 2 sigma over square root of N. Everything has a formula. Estimation means assigning values to a population parameter based on the value of a sample statistics. In other words, you start from somewhere in order to have an idea about the population. You start with X bar in order to make a decision about the mu, and you make up an interval. The confidence level is denoted by 1 minus alpha 100%. The maximum error, also known as the margin of error of the estimate for mu based on known sigma, is the E that was here, Z alpha over 2, sigma over square root of N. The parameter or parameters of T distribution is only df, degrees of freedom, everybody. Degrees of freedom. What criteria are required to apply the T distribution to make a confidence interval for mu? The sample must be a simple random sample. Randomization is always important in statistics. Either the sample is from a normally distributed population or N is large. How large? Larger than or equal to 30. Finally, the population standard deviation sigma is unknown. So we use the T distribution when sigma is unknown. And in most cases, sigma is unknown because we don't have access to the population standard deviation. Sample statistic is used as a point estimate, which is a specific numerical value estimate of a parameter. A point estimate is a single value or point used to approximate a population parameter. Example, the sample population P hat is the best point estimate of the population proportion P, or for example, we use X bar for mu. Confidence interval. We can use a point estimate to construct a confidence interval estimate of the true value of a population parameter. Here's the T table. Of course, as always, you can use technology, but we will discuss the table. That's what has been used for a long time. So find the values for T, for a T distribution with a given sample size and a confidence level. So that's what the T score is. So we have, in this case, area in one tail. This is called the tail. Area in two tails. For example, if you're looking at 90% confidence interval, which is in the middle, the 10% is distributed over the two tails, so each one is 5%. So alpha is 10%, alpha over 2 in each case is 5% as an example. That's why you may look at one tail or two tails. You use degrees of freedom on the left side, and then you do the reading. That's how it works. Let's look at a couple of examples. Find the value for T, for a T distribution with sample size of 20 and a confidence level of 95%. So it's a good idea to have the drawing. 95% confidence interval means in the middle we have 95%, and the tails they add up to the rest. One minus that, that means 5%, which means each one is 2.5%. That's why they use alpha over 2. So okay, if this is the confidence interval, alpha is 1 minus that, which is 5%. This is just for the sake of argument, so we understand the concept. And so here's the table, and here's a portion of the table. On the left column, we have degrees of freedom. I have up to 5, and then I change numbers because I don't have enough room. At the top, you see two things, either area in one tail or area in two tails. For example, this has to be 2 times that, this has to be 2 times that, just to give you an idea. So what is given in this case? Degrees of freedom is n minus 1 because sample size is 20. So n is 20. Degrees of freedom is 19. And we want 95% confidence interval. So if there is a 95% confidence interval, that means alpha in two tails is 5%. Area in two tails is 5% or 0.05. Alpha over 2 in one should be half of that. So we are looking at degrees of freedom on the left. Area in two tails, 5%, right? 1 minus 95%. And in one tail is half of that. So these two coming together will give us this number. And that means over here is positive 2.093. Over here is the same thing, but negative. So t would have a value of plus minus 2.093. That's how you do the reading. Find the value of, again, you can do it by technology, we'll discuss that, but this is how we read tables. Find the values for the t, for a t distribution with a sample size of 30 and a confidence level of 90%. By the way, again, they're given a sample size, that means degrees of freedom is n minus 1, which makes it 29, 30 minus 1. Sometimes they give us degrees of freedom. But now we have a 90% confidence interval. Let me erase my work. So now this is 90%. So the confidence interval right in between is 90%, which means alpha is 1 minus that, 10% or 0.1. And obviously, alpha over 2, in each tail, we have half of those. That means 5% in each tail. Total area in two tails is alpha or 10%. So degrees of freedom is 30 minus 1 or 29. So we go to the left column and look for this number 29. And then we go to the top row and look for alpha of 10%. That means area in two, okay? Area in two tails is 10%, 0.1 or 10%. And in one should be half of that. So we are looking for those. Now put these two together. Results in this number. So that means over here is positive 1.699, and over here is the same thing but negative. So t is plus minus 1.699. Again, just to make sure you can read tables, but you can also use technology. For example, if I want to use the TI, okay, T distribution, find TD score. Second variable is inverse T, similar to normal distribution. To enter is left area and degrees of freedom. You need the left area. So if we um, are looking at this one, alpha is 10% left area. That means the area in, one tail is 5% or 0.05. So we would put 0.05, 29, and that gives us the answer. Now, it gives us the answer for this one. And that means we should recognize for this one is the same thing but positive. Okay. Now, granted, if you put 95.95, it gives you this value. But there's no need for that. You find this, and by symmetry, you know this must be positive. You could use a T-distribution calculator from Star Trek, from good calculator, from Excel. I'm giving you various ways of using technology, okay? If you're comfortable with Excel, you can do that. Find the critical chi-square value for 20 degrees of freedom when the area to the left is 0.01. Find the critical chi-square value for n equals 30 when the area to the right is 0.9. So what is this now, the chi-square? The chi-square distribution must be used to calculate confidence intervals for variances and standard deviations. The chi-square variable is similar to the t variable in that its distribution is a family of curves based on the number of degrees of freedom. The symbol for chi-square looks like x squared. It's a Greek letter chi, pronounced chi. A chi-square variable cannot be negative, and the distributions are skewed to the right. So it looks like that. It is skewed to the right. It starts from 0 and goes to infinity. The total area under the curve, because it's a probability distribution, must be equal to 1, and it is, okay? And when you look at the table, similar to the T, on the left side, we have degrees of freedom, and on the top, we have alpha. Now, this one, the way you read it, you need the degrees of freedom, and alpha represents the area. If you look at this one, is area to the right. In other words, if they have given you area to the right, so be it. If they have given you area to the left, you have to subtract it from 1 because the total area is 1. So degrees of freedom is given. I don't have to subtract 1. Area to the left is 0.01. This is given. And therefore, what is missing is area to the right. The way this table works, you need the area. Take a look. Area to the right. So area to the right, remember the total area under the curve is 1, so subtract this from 1. So we need degrees of freedom and area to the right, A sub R, this is A sub L. And so we write 1 minus 0.01. The area to the right is 0.99. So what do we do? On the left column, we look for degrees of freedom, 20. So this is 1 to 7, so we need more, and I don't have enough room, so I give you the row that has the degrees of freedom 20. Up here must be 0.99. Up here must be 0.99. And putting it together gives us 8.260. That's the answer. Now, I can write chi squared when the left area is 0.01. is the same as chi-squared, where the right area is 0.99, and the answer is 8.260, or simply chi-squared is 8.260. Part B, n is 30, so degrees of freedom is 29, n minus 1. And area to the right is given. So we need two things. We need degrees of freedom is 29. We need area to the right is 0.9. So again, I didn't have room, so I'm going to put another row with degrees of freedom being 29 and area to the right be 0.9 or 0.90. So those two we need. And when you put them together, you end up here. So chi-squared has the value of 19.768. And you can write chi-squared when the right area is 0.9, or chi-squared when the left area is 1 minus that. This is 0.1, and that's 19.768. So it's fairly straightforward, and as I said, you can always use technology. For example, there's a critical chi-square calculator. You can look that up. You really want to get comfortable with various calculators to see which one works best for you. Now, let's do some more. A statistician is interested in estimating at a 95% confidence level the mean number of houses sold per month by all real estate agents in a large city. It is known that the population standard deviation is 1.9. How large a sample should be taken so that the estimate is within 0.65 of the population mean? First and foremost, you need to read this a couple of times and write the given symbolically. So what is given? 95% confidence interval, population standard deviation, sigma is 1.9, and we want the estimate E to be within 0.65, so E is equal to 0.65. So this is writing the given symbolically, and I'm going to remind you of some of the formulas you can find in your formula sheet. Confidence interval, when standard is in general for the mean would be x bar plus minus. When population standard deviation is given, sigma of x bar is sigma over square root of n, is z alpha over 2 sigma over square root of n. And by the way, for this part, how large a sample they're looking for n. If you look at this formula, everybody, look at this formula. If you square it, becomes e squared z squared sigma squared over n. And if you solve for n, solve this equation for n. This is elementary algebra, gives you this formula. So if I want to solve for n, I need sigma. I can see it here. I need E. I see it here. But what is Z of alpha over 2 comes from the fact you're dealing with the 95% confidence interval. Now, 95% is one of those common intervals. So this is 95%. That means the two tails would be 1 minus that, or 5%. That means each tail is half of that. So half of 5% is 2.5% or 0.025. And the Z value is plus minus 1.96. This is one of those common values. So perhaps you want to remember that. And now we are ready to plug in. Everything is given plug in. Replace the Z of alpha over 2 with 1.96. Sigma with 1.9. So that's the formula. And plug in. and E with 0.65. Calculate this and then raise it to the power of 2. Always write with decimals. However, it is extremely important to understand what happens here. Doesn't matter you have 32.82 or 32.1. You must round up to 33. Here's the reason. A sample size is a discrete number, is a countable number. So you either have to go with 32 or 33. Why do we go with 33? I want to make sure we understand that. Not just because it's 30.82. Let me, in fact, just assume it was 32.1. Even that, both of them will change to 33. Why is that? This calculation says, if I want to make sure that the estimate is within 0.65, I need at least this many. So if I need 32.82, I have to round it up to 33. But what about 32.1? If I go with 32, I don't have enough samples. So you always round up, even if it's 32.01, round up, always. All right. Now, find this 95% confidence interval if the mean for such sample size is 3.4. And that is X bar is 3.4. The formula is X bar plus minus E, or mu. And what does that mean? Mu is between X bar minus E and X bar plus E. Please understand, sometimes they want you to answer it in this format. Sometimes they want you to answer it in this format. So answer it properly. So in this case, if I go with that, X bar is 3.4. So minus E is 0.65, and the same thing plus that. Do the math, and mu, the population mean, is somewhere between these two numbers. What does it mean? We are 95% confident that the true population mean is between these two numbers, 2.75 and 4.05. Or, and you want to elaborate, for real estates, the mean number of houses sold per month by all real estate agents in that large city, if you want to continue finishing it up. In this case, a random sample of 20 female members of a health club showed that those 20, spend on average 4.5 hours per week doing physical exercise with standard deviation of 0.75 hours. Assume the time spent on exercise for all female members is approximately normally distributed. What is the value of the point estimate of the population mean? Well, first, let's write what's given. What's given is that we are saying, okay, it's approximately normal. So we are dealing with ND, normal distribution. Sample of 20, N is 20. Average is 4.5, X bar is 4.5, standard deviation of 0.7. Please understand why I'm saying X bar and not mu. It says a random sample of 20 female members of a health club showed that those 20, so this pertains to 20, not the population, so that's X bar. Also, standard deviation is for those 20, so it's S, not sigma. So first we write the given. So we have a ND, short for normal distribution. N is 20. X bar, because it's a sample. S, because it's a sample, are given. And in general, we want the point estimate of population mean. Point estimate of mu is X bar, which is 4.5 hours. Okay, now we want to construct the 98% confidence interval for the mean time spent on physical exercise of all such females. So we got everything, and now we want to come up with the 98% confidence interval. Uh, Confidence interval is x bar plus minus e. But for the case that sigma is missing and we have to go with the t distribution, instead of sigma of x bar, we're going to go with s of x bar, s over square root of n. And e is t alpha over 2 s over square root of n. I hope you see how similar it is to the formulas that we've seen for the population. Extremely close. So it's just slightly different symbols. So we want 98% confidence interval, which means alpha is 0.02. That means the total area in the two tails is 0.02. That means each tail is half of that 0.01, just in case. So we have 98% here. Alpha is 2% or 0.02. That means each tail must be 0.01, each tail. Okay. So let's see what we have. Any stone, degrees of freedom is n minus 1, 19. Now, if you want to go with the technology or if you want to go with the table, you need degrees of freedom. And you go with area in two tails of 2%. And you find the t values are plus minus 2.539, which means this one is negative, this one is positive. Okay, everybody? Remember, right in the middle, we have 0. T equals 0. Just like the normal distribution. So we have x plus minus e, x bar minus e less than mu, x bar plus e, and e has this formula. So we are going to evaluate the e. We have everything. T 2.539, parentheses S 0.75 over square root of n 20. Just plug it. Put it into a calculator. You get 0.4258. And you are going to find x bar, which is 4.5. Subtract this number from it and add to it. And you get the following, everybody. So mu is between these two numbers, 4.0742 and 4.9258. Again, sometimes they want you to write it in this fashion. I want to just, if they ask you for this format, everybody, so pay attention to you so you don't make a mistake. If they ask you for this format to answer, then the answer would be 4.5 plus minus. The E is 0.4258. Sometimes they ask you for this format, and that's how you answer. So pay attention to the format they ask you. Okay? And so we are 98% confident that the true population mean is somewhere between these two numbers for this case. As far as technology is concerned, uh, to find the confidence interval, you go to stat, test, t-interval, enter data, or stats, because sometimes they may give you data and that means you have to calculate the X bar, S, and so forth. And then enter. In this case, we go with T interval. X bar is 4.5, S is 0.7, N is 20, and confidence level 98% or 0.98. You do the calculation and take a look at what we have here. Of course, the reason they are slightly different, this one is 4.0742, this one is 4.0741, and this one ends with 8, this one ends with 9, because calculator uses a, a more precise value for the t, and therefore the numbers are slightly different. So you should be able to use a calculator as well. Okay, so just for the sake of argument, okay, to use a calculator, we click on stat, you go to test, after the z interval, we get the t interval, enter, data, we go to stats, X bar 4.5, S is 0.75, 0.75 or 0.75 makes no difference. N is 20, confidence level of 0.98 or 0.98. Calculate. And as you can see, the numbers at the very top, 4.0741 to 4.9259. I just wanted you to see how we use a calculator. In this case, a TI calculator. All right, so we went through that. It's important to write the given, write the formulas, and then if you want to use a calculator, you have to justify your work. It's just using a calculator by itself, it doesn't mean you understand the concept, so you want to show, and that's important to do it accordingly. And so with that being the case, here's the next question. Out of 500 randomly selected adults, 300 said they were in favor of the death penalty for a person convicted of murder. What is the value of point estimate of the population proportion? So obviously we are dealing with a proportion, we are dealing with binomial distribution, we are dealing with either they are or they are against, the death penalty. So there are two outcomes. So the point estimate of the population proportion P is P hat. Okay. So given you're dealing with the BD binomial distribution, N is 500 and X is 300. Point estimate of P is P hat. As you know, P hat has the formula X over N. So 300 over 500, and you change it to 3 over 5 or 0.6. If it keeps on going, you better stick with the exact answer, which is a fraction. But this one, because the denominator has a factor of 5 only, you come up with an exact answer writing the decimal as well. Better yet, a terminating decimal. That's what we mean. What is the 95% confidence interval for the population proportion? It's similar to the mean. In the case of a mean was x bar plus minus e. In this case is p hat plus minus e. Okay. So p hat plus minus e, where mu of p hat is p, sigma of p hat square root of pq over n. Now, if we don't have access to p and q, we may use p hat q hat over n square root. And so E becomes Z alpha over 2, and we don't have this one. We use this one square root of P hat Q hat over. What I want to explain here, remember that when we uh, use normal approximation to binomial distribution, we are approximating it. And that's exactly what happens here. And one approximation is bad enough. You never ever use T in the case of proportion. Okay. You always use Z. And so we have P hat, which means we can calculate the Q hat also. We have the formula. So this is the formula we need to use. And with that being the case, we need to find the Z P hat, Q hat, N. Well, we have the N, we have the P hat, Q hat is 1 minus P hat, so 1 minus 0.6, which makes it 0.4. Now, how do we find the Z? 95% confidence interval. As we mentioned, it's pretty common. And for a 95% confidence interval smacked in between, the two tails have the area of 5%. Each one is half of it, or 0.025. And the Z value is plus minus 1.96. And of course, we would use 1.96. So we have everything. And now the Z is 1.96. Plug it. 0.6 times 0.4 divided by 500, take a root times 1.96, and we'll get 0.0429. Again, you want to carry out as many decimals as possible just to be on the safe side. So P hat plus minus E, that means 0.6 plus minus 0.0429. Again, please pay attention to what I wrote here. This is one format they may ask you. Fine. But normally, we want the P to be between two numbers. That means P is between 0.6 minus this number and 0.6 plus this number. And you come up with P being between these two numbers, 0.5571 and 0.6429. Again, if you were to use technology, for example, TI, okay, the confidence interval, one proportion, stat, test, one proportion, Z interval, you put X, N, and confidence level. X is 300, N is 500, confidence level of 95% or 0.95. It gives us the same answer as you can see here. Now, if I were to stop here, 0 changes to 1 because of number 6, and then 6429, and it remains. So pretty good. Now, what does it mean? We are 95% confident that the true population proportion is between the two numbers, 0.5571 and 0.6429. That's the meaning of it, everybody. How large a sample is needed to be 99% confident that the margin of error is 0.025 for percentage of golfers that are left-handed if we assume that 15% of the golfers are left-handed based on a previous study. Um, First of all, let's see what's given here, class. Right here, 99% confidence interval, margin of error E is 0.025. And assume that 15% of the golfers are left-handed. This is P hat. So P hat is 0.15. So we are looking at what's given. And again, reminding you of the formula, confidence interval is P hat plus minus E. Sigma of P hat squared of P hat Q hat over N. E is the alpha over 2 squared of P hat Q hat over N. If you look at this formula and solve for N, which means square both sides, this becomes E squared, this becomes Z squared, and this comes out. And if you solve N, just put the N here, put the E down here, this is being squared, this comes out, and this goes down, becomes E squared. So that's the formula we're going to use because how large of a sample is needed? We are looking for N. N is a question mark. We are looking for N, everybody. So 99% confidence interval looks like that. So we have 99% here, which means 1% belongs to both tails, and each one is half of it, or 0.005. That happened to be a common value I showed you in the table, and those are plus minus 2.575. So with the confidence interval of 99%, now we have the Z value, and we are going to use everything we have in this formula. And of course, to do that, what's missing is Q hat. If P hat is 0.15, Q hat is 1 minus that, 0.85. And so now we are ready to use the formula. So we are going to use this formula, everybody, and we are going to plug in. See, that's why the given helps. Understanding what the question is asking us. Plug in. Replace the Z with 2.575, P hat with 0.15, Q hat with 0.85, E is 0.025, and then square. Put it into a calculator. And again, this must be rounded up. Granted, it's 6 anyways, you would round it, but even if instead of 6 you have 1, you will round this to the nearest whole number, 1,353, because it's a discrete value. You're talking about the size, how large a sample is needed. Now, same question, part B, assume that we have no prior information. See, part A says P hat is 0.15. Part B says we don't know about P hat, no prior information, suggesting a possible value for the sample proportion. When that happens, class, we use the most conservative estimate. That means we don't know P hat and Q hat. It has been shown that if you take them to be identical, P hat equals Q hat equals 0.5, okay, then it gives you the most conservative estimate, which means whatever n is larger than that. If the n you come up with is smaller than that, you made a mistake somewhere. So we got to assume P hat equals Q hat equals 0.5. And again, the same confidence level, the same E. And over here, P hat times Q hat, 0.5 times 0.5 is 0.25. Sometimes you see this formula, class. This comes from the fact that the product of P hat, Q hat, then it's 0.5 times 0.5 is 0.25. That's where the number comes from, okay? Now plug in. What are you plugging in? the Z 2.575, the E 0.025, and notice this number is larger than that. And here's what I mean. Take a look. If you were to round it accordingly, you would get 2,652, but that's not what we are doing. We round up, because this means we minimum need this number. And since it has to be discrete, the whole number, 2,653. That would be the proper answer. You want to be very careful with that. Okay, we are ready to move on. Always round up. Always round up. I can't really emphasize this enough because sadly that is a common mistake. Sometimes students don't. All right. Given n equals 30, x bar is 80, 0.5, s is 4.6. Assume normal population. Find 98% confidence interval for the population variance and standard deviation. Class, there's not much to write as far as the given because it is given to us symbolically and everything is there, including the confidence interval of 98%. So what do we do now? First, I'm going to give you the formula. The confidence interval for sigma squared or the variance has the formula n minus 1 s squared over chi squared of the right less than sigma squared less than n minus 1 s squared over chi squared of the left. But normally we want for the standard deviation. Normally we don't want this, but in case. In order to get to this, you want the confidence interval for sigma for the standard deviation, for the population standard deviation, you have to take a root. So you calculate this and then you take a root. So after this is done, this is just one very fast and easy step. In any event, so to do that, we are going to use chi-square table, although you can use, remember, you can use technology, everybody, for that instead of the table. So we want a 98% confidence interval, okay? So this is, now the confidence interval, the way it works, remember, for chi-squared, we go from 0 to infinity, and so 1 minus alpha is in between. That means 98% is in between. And then 2% cut it in half. Each one is 1% here. So, and degrees of freedom is n minus 1. N is 30. So degrees of freedom is 29. So df is n minus 1, which makes it 30 minus 1 is 29. We are dealing with 98% confidence interval, which means 1 minus that 0.02 is the total area in the two tails. If the total area in the two tails is 0.02, the area in each tail is 0.01. So this is 0.98. This area is 0.01. This area is 0.01. So this is called chi-squared of the right. Remember, in order to come up with the value, you need two things. You need degrees of freedom. So degrees of freedom is 29. And you need the area to the right. So chi-squared of the right is very easy. The area to the right is 0.01. So you're going to write for chi-squared of the right, for this one, you need area to the right, 0.01. Degrees of freedom is 29. Put 29 and 0.01 together. And when you put them together, you end up with what number? 45. 49.588. That is chi-squared of the right. Now, for chi-squared of the left, the area to the left is 0.01, but you need the area to the right, which is 1 minus that, which is 0.99. You need the same degrees of freedom, but you need the area to the right. The area to the right is 0.99, and you are going to locate that. And that gives you this number. When you put these two together, gives you 14.257. So you're going to write chi-squared of the left is 14.257. Now you put that into this formula. The numerator is the same for both of them. N minus 1, 29. S, 4.6 squared. So the numerators are identical. Chi-squared of the right, 49.588 goes here. Chi-squared of the left, 14.257 goes here. Okay. Now you do the math. So sigma squared. In other words, what is the confidence, 98% confidence interval for the variance? Sigma squared is this, between 12.3748 and 43.0413. What about the standard deviation? Just take a root of all sides. This becomes sigma. Take a root of this number and take a root of this number and put that into a calculator. And the 98% confidence interval for the standard deviation is the following, between 3.5178 and 6.5606.